Okay, I'd like to welcome everyone to our very first virtual lab. In this lab, we're going to focus on the energy that is released as the electrons move from energy level to energy level. So we're going to use a Bunsen burner to supply that energy to make the electrons move up in energy levels. And then those electrons will naturally fall back down. When they fall back down into these lower energy levels, they release energy. And the way they're releasing this energy is as light energy. So I have a series of metal samples that we're going to go through and look and see what type of light is released based upon the metal. You can see this first one is a copper solution. So we want to see what is going to happen based on the electrons moving in the copper. So what I would like for y'all to do is to go ahead and open up your virtual or digital notebooks to page 31. And we have the samples. So I'm going to go ahead and move this down. You don't need to really see me as much as you do the Bunsen burner. So I have a Bunsen burner here, and you can see the little window. We always want to light the Bunsen burner with the window closed because we don't want it to have a lot of air to begin with. So I turn the gas on. Hopefully y'all will be back in a few days, couple weeks, and we'll be able to do these in person. So I'm going to open the window, and you can see that now I have what is called a double cone burn. So on the interior you see a cone, and then you see a bigger cone on the outside. Well, I am going to take a Q-tip and I'm going to dip it into my copper solution, and we'll see what happens. So I'm just going to put it right here. I'm going to slowly spin it. You can see it almost immediately starts flaming up, and you can see that it flames up a nice, pretty, and that color is what you're supposed to record. So I'm going to do it again. That one was pretty quick. Alright, so here we go again. And I know sometimes it's kind of tough. That's why I put this board behind us. It's a black board. It helps a little bit distinguish the colors. Here we go. I'll get another one. There we go. Can you see that now? You can see it flaming up. Alright. So I may have to help you just a little bit. So that was a green color for the copper. Now we have another solution. This has a strontium nitrate. So this is element number 30, or I think it's 38, somewhere right along in there. It's called strontium, and it's a metal. And as I do this one, nothing happening yet. I'm just kind of twirling it back and forth. As it dries out, there we go, a little spark here and there. See what's going to happen. Are you getting that one? Oh yeah. Ah, that's a good color change. You can definitely see that one. And that's going to be a nice pinkish. Do it on this side. Maybe you can see it on. Yeah, it's a nice pinkish color. So I'm kind of helping you a little bit with the colors, but I want you to not so much not be able to see them, but I want you to understand what we're going to do with this. So every element, because it has its own unique set of electrons, is going to produce its own unique color bands. So if I look at this, you'll see that this is going to be a barium nitrate. And barium, if you look at it, I don't know, what would you call that? Almost a, I think I would call it kind of like a flesh color. I don't know, maybe like your lips, or not quite a real soft skin color maybe. Let's do that one again just to see if we can get a better color reading. Now, I'll hold it up a little bit. Sometimes, see if I can get it dried out just a little bit. All right. Can you see that kind of flashing up? Yeah. All right. Now, one of the things that I want you to realize is sometimes you'll get these yellows in your color changes. Like that one was kind of a fleshy color, but every now and then you'd get like a yellow. Well, if it looks like the color of paper burning, then I'm probably burning the Q-tip. So let's keep going. All right. Oh, I'm sorry. This one is a lithium nitrate. And let's see what color lithium is going to be. It's got a little bit of a color. Ooh, yeah. Definitely got a big color change on that one. That is I call that a shock pink almost. You can definitely see the pink in that one. So that meant that lithium and strontium were pretty closely related. This is sodium. It's actually a sodium chloride, which is nothing more than a salt solution. And bam. Yeah, that's pretty much yellow, right? That's the color of sodium. That looks like paper burning, but it's not. That's the only element that has that same color as the paper. All right, I'm going to give you a potassium nitrate. Notice it doesn't matter what the solution, it's the metal that we're actually looking at. So all potassiums are going to be this color, and this color is, ooh, it looks like, let's wait just a second. I don't know if y'all can see that one yet. Here it comes. Yeah, it's got a lavender, kind of a purplish color to it. Yeah. All right, so that one has a little bit of a lavender or a purple color to it. And the last one that I want to do is the calcium. So I'm going to sit here and do it. And this is a calcium nitrate solution. Just wait just a second. There it comes. The calcium nitrate is kind of a yellow, but it's got a little bit of pink in it. So that one's going to be a little bit different from the calcium. It's a lot different from the other pink ones. Now, what do we do with these? Well, guys, hold on just a second. If you know that all of those are going to have very specific color bands whenever you heat them underneath this, then we can use that to help us determine what unknowns are. So you can go through, and I'm going to pick number 1. And we've got all of these other ones already recorded. That was on page 31 of your digital notebook. You were recording the colors that you saw. So I'm going to now come over here. And this one is, and I look at it, it's kind of a whitish color, but it's got a little bit of yellow to it. Which one had that yellow color? Not dark yellow, but a lighter yellow. So we would have to go back in and make sure that we're doing our notes so that we could determine the different shades of them if we had to. So what unknown do you think that is? This is going to be in page 32 of your digital notebook. We have 3 unknowns. Now I'm going to do this one. All right. Here it comes. There it comes. Nice. Now you can see that it's got that nice green color to it. But guys, sometimes you don't even have to have the color bands because, look, the solution itself is colored. We did have a colored solution over here, and it was our copper nitrate. So I would assume that the ion that's in this solution is a copper ion as well. And that's unknown. Oh, I'm sorry, I went out of order. That was unknown 3. Sorry about that, guys. This is unknown 2. So if you need to retype that, you can. So this is our unknown 2. Oh yeah, almost. Wow, look at that. That's that real dark pink. We had one that was lighter, and we had one that was like, bam, a dark pink. And that would definitely be the one that's the darker of the pinks. So I'm going to go ahead and turn this off. So what were you supposed to get out of this little virtual lab? Number one, you need to see that whenever a metal is heated, its electrons will move energy levels, and when it does that, it releases different energies. That energy can be released as different color of light. That's what we saw here. If you know that, then you can go back in, record, and figure out what colors each one of your elements or metal elements are going to exhibit, and then you can use that to help determine unknown solutions. So hopefully you were able to get the different color bands. If you were having trouble with them, just go back and rewatch the video, and I give you voice colors of them too. And I know that's not quite as good as you being here and actually doing this, but we had to make do on what we have. All right, well, I look forward to seeing you again, and I'll talk to you a little bit later.